Hey there. So, have you ever stopped to think about what kicking a soccer ball, pushing a grocery cart, or even just flipping on a light switch all have in common? Well, they're all explained by three super fundamental ideas in physics: work, energy, and power. Now, these aren't just words we throw around. In science, they have really specific meanings that kind of unlock how everything around us moves and changes. So, let's dive right.
So here's our game plan. First, we're going to tackle what work actually is in the world of physics. Then, we'll look at energy, the juice that makes work happen. After that, we'll get into power, which is all about how fast things get done. And finally, we'll pull it all together. Sound good? Let's do it.
All right, first up, what is work? And I want you to just forget everything you think you know. We're not talking about homework or your 9 to 5 job. In physics, this word has a very, very precise and honestly a kind of surprising meaning. Okay, let's start with a little thought experiment. Picture this. You spend the entire day pushing against a solid brick wall. You're using all your strength, you're sweating, you feel totally exhausted. You've put in a ton of effort, right? But here's the million-dollar question. According to physics, have you actually done any work? And the answer is nope, not a single bit. Crazy, right? Here's why. The scientific definition is super clear. For work to be done, the force you're applying has to actually make the object move. That movement has a fancy name in physics, displacement, and it is the one thing you absolutely need. No movement, no work. That's the rule. So this is the golden rule, the one thing you gotta remember. For work to happen, you need two ingredients: a force, which is your push or pull, and the object has to move. If you push on that wall and it doesn't budge 1 millimeter, there's zero displacement. And if there's no displacement, it doesn't matter how hard you pushed, you've done absolutely zero work. And being physics, of course there's a nice simple formula for this. Work equals force times displacement. Super straightforward. W is for work, F is the force you apply, and S is the distance the object actually moves. So let's try it with some numbers. Say you push a box with a force of 10 newtons, which, by the way, is about the force it takes to hold up a big 1-liter bottle of soda. If you push it and it slides 5 meters, you just multiply those together. You've done 50 joules of work. And that joule is our official unit for work. Okay, so that's work. Let's move on to the next big idea, which is totally connected. If work is the thing you do, then energy is the fuel you need in the tank to get it done. And the definition is just beautifully simple. Energy is nothing more than the capacity to do work. That's it. So think back to pushing that box. To do 50 joules of work, you had to have at least 50 joules of energy in your body to begin with. Makes sense, right? Now, energy is a pretty huge topic. So scientists like to break it down, and the two main types are all about what an object is doing. Is it moving, or is it just about where it's located? And this slide lays it out perfectly. On one side, you've got kinetic energy. Think of that as the energy of motion. A rolling bowling ball is a perfect example. On the other side, you have potential energy. This is stored energy, like when you stretch a rubber band. It has the potential to do work, but it's just waiting. Let's talk about kinetic energy first. This is the energy something has just because it's moving. A car driving on the highway, a bird flying through the air, even a tiny raindrop falling. They all have kinetic energy, and the faster they move, the more kinetic energy they have. Now, this formula might look a little tricky, but just focus on one part. The V for velocity is squared. That little 2 is huge. It means that speed has a massive, massive impact on energy. If you double your speed in a car, you don't just get double the energy. You actually get 4 times the energy. It's why high-speed accidents are so much more dangerous. So, for example, a 2-kilogram ball moving at 4 meters per second, well, it has 16 joules of kinetic energy. And hey, look at that. The unit is joules again, just like it was for work. All right, now for the other side of the energy coin, potential energy. This is that stored up energy. The energy an object has just because of where it is or how it's shaped. It's energy that's just waiting to be used. And its formula is pretty simple. P equals mgh. M is the object's mass. G is the acceleration from gravity, which is basically a constant number here on Earth, and h is the object's height. So, the higher you lift something, the more potential energy you're packing into it.
So if you lift a 5-kilogram weight, say 10 meters up in the air, you've given it 490 joules of potential energy. That means it now has the ability or the potential to do 490 joules of work if you let it drop.
Okay, so we've covered work, and we've covered the energy needed to do it. The final piece of our puzzle is power. And this one introduces our new best friend, time. Power is all about how fast you get the work done. The definition really says it all. Power is the rate at which work is done, or, how fast you do it. Think about walking up a flight of stairs versus running up them. Either way, you're doing the exact same amount of work, lifting your body to a new height. But running up feels way harder because it requires a lot more power. And that brings us to our last formula for today. Power is just work divided by time. This is exactly why running up those stairs is tougher. You're doing the same W, the same amount of work, but you're doing it in a much smaller T, or time. And that means your muscles have to generate a whole lot more power. Let's look at a quick example. If you do 200 joules of work over a span of 10 seconds, your power output is 20 watts. The unit for power is the watt. You've probably seen that on light bulbs. And it's named after the inventor, James Watt. Whew. Okay, we have covered a lot of ground here. Let's take a second to pull everything back together and do a quick final summary of how all these ideas connect. And here it is, your very own physics cheat sheet. So we've got work, which is a force causing something to move. We've got energy, which is the ability to do that work, and it comes in kinetic for motion or potential for position. And finally, power, which is how fast you're doing that work. See how work, kinetic energy, and potential energy are all measured in joules? It's because they're all so closely related. Power gets its own special unit, the watt. And that's our look at work, energy, and power. But I want to leave you with one final question to chew on. We learned that to do work and to move, you have to push on something. So, in the total emptiness of space where there's nothing to push against, how on earth does a rocket move forward? It's a really cool puzzle, and the answer lies in another one of Newton's famous laws. Thanks for joining me.